Joost Cassee for continuous delivery of a Python web project in Docker and Ansible. Thank you.
Okay, let's see if this still works. It does, very good. Okay, hi everyone. My name is Joost Cassee and I'm going to talk to you about one of my favorite subjects which is continuous delivery. My other favorite subject is hypermedia, and we are going to do continuous delivery of a Python hypermedia API, so that's, well, my best day that I'm having, basically. So first, a couple of things. You can follow the slides at the first URL on screen, and then the code that contains both the project that we are going to deploy, and also the deployment scripts themselves is on the bottom URL. You can follow along. So my background is, well, basically programming. I love programming and software development. I love the fundamental computer science stuff and psychology and the organizational problems of developing software in large teams. I'm one of the co-founders of Painless Software, a software consultancy company, and technical lead at GoAbout, which is a trip planner for urban transport, basically Google Transit, only with booking and payment in it. And I created a couple of Django and hypermedia related open source projects. So the problem that I'm going to describe today is delivering software, right? So the classical way of delivering is just, well, you develop the code, you make a release artifact, you do quality assurance, you deploy to an acceptance environment, you do the other stakeholders like users or operations or functional managers do some acceptance testing, and then you or they deploy to a production environment. But the problem, of course, is that you will find and fix bugs after developing. You will have mistakes in the release process. You will find bugs in the quality assurance process. You will have to go back and fix those. Then you have to make a new release. And then during the acceptance, you will again have mistakes in the deployment because there are other people. You will find new bugs that you will need to make new releases for. You will need new deployments to the acceptance infrastructure. And finally, when you go through all that, you always find, I found that if you're not doing the deployment to production yourself, but leaving that to, for example, an operations department, there's communication problems there, and there will be problems there which you will have to fix. And this means that in large organizations, it can take up to a month to release a piece of software, unfortunately. So I was just at a job that prided itself for having a release after 6 months, basically. So why is this? Well, basically, it's all guys waiting around, waiting for the other guy to deliver his work. And then if you're waiting around and finally get your hands on something, you're really a bit of a... If you don't contribute something to the process, you have no reason to exist, right? So every one of these steps has an incentive to find problems along the way, just to stay relevant within the whole release process. So what if instead of putting all these guys in line, we could get them all together and let them hash it out feature by feature as we develop individual features. Because if you think about it, what's really going on is that the deployment phase has a lot of the same problems that the development phase has. So you have bugs, you have changes, you have a lot of people trying to, you have basically change management. And what I think is happening is that in the development phase, we've started to have these nice agile processes, iteration, And in the deployment phase, we are still basically doing waterfall processes. Now, imagine, like I said, that we would integrate those two things. We would treat the infrastructure in the same way as we treat our code. We will treat deploying the project just as a regular part of the software development project. So that means that the deliverable of your development process is not a release artifact like a Python package or something like that, but it is working code running on production. And so today I'm going to show you a very specific, very concrete case of that. Namely, we will use Ansible to describe the infrastructure. We will keep this description, and Ansible uses things like playbooks and roles. We will keep this in a Git repository. We will host this Git repository on GitHub. We will use a continuous integration engine, in this case Travis CI, to automatically build not just the code, but the whole infrastructure. And we will require pull requests not just for changes in the code, but also for changes in the infrastructure. So this means that for this to work, this change management to work, that means that any pull request must first of all be deployed somewhere. Because not just the developers need to review the changes, but also non-technical people, like product managers, operations people, and they all need to sign off on every single change. And so that means that you bring the whole acceptance stuff that you used to do for a whole release, and you bring that down to a feature or a change level. And that means all of these guys, like developers, testers, operations, application managers, and even customer support, all need to be on board with a specific change for this change to be accepted into the mainline Git branch. And of course, the effect that we hope to get by this is to have all of these people who usually don't get along to finally get along. Now, before I show you, there's two questions, of course. The first one is, why use Docker for this? And there's a lot of talk about Docker, so I'm not going to describe what Docker is. I'm going to describe what the two main important functions are in Docker that make it so good for continuous deployment. And the first is that when you change your infrastructure, this is always a very stressful and high-risk time, because you are changing the production environment. And these changes, if they fail, for example, you are left with a production environment that's in an unknown state. So changes to the infrastructure are relative, at least to the production environment, are relatively high risk. And Docker lets you take a lot of those changes and take them away from the deployment process and move them into the build process. Because you build Docker containers, and the only thing you do during the deployment is to restart a new version of a certain Docker container, which is a much simpler process than updating Python packages, new dependencies, all that kind of stuff. So this is the first reason to use Docker. And the second reason to use Docker is that I'm using, in this case, Travis CI, but I don't want to be married to Travis CI. I want this process to be able to run anywhere. So I'm using Docker containers to run parts of the build process. And that means that you can run this process on Travis, on Circle CI, on your own Bamboo or Jenkins server, or even on your own laptop, if you want. So that's why Docker. Now the question is, why Ansible? So there's a lot of different ways of deploying Docker containers. There's stuff like Docker Swarm, Kubernetes, and those CoreOS, those kind of projects. And at the moment, I find them scary as hell still. They're really magical to me. I don't really understand them yet. Many of them are still in beta, and only some brave people are using them in production. So I wanted to have something that I really understand, and I can see the nuts and bolts of what's really happening on the servers. But there's also, of course, other infrastructure orchestration and configuration management tools, such as Puppet and Chef and SaltStack. And so the only reason, basically, for me to use Ansible is that it was designed by the product manager of Puppet. So what better endorsement, right? So this is why I'm choosing Docker and Ansible to get this whole process running. Now, what I want to do in the next, say, 20 minutes is give you a tour around the code that makes this all possible. But before I do that, I want to show you how the quick overview of how this process works. So like I said, we start with Travis CI, which is the continuous integration service that this project uses to build the whole infrastructure. So we start with the Python code. And we build a Docker container from the Python code. Then we test the Python project by running the tests inside of the Docker container. And then we push the Docker container out to Docker Hub, which is a centralized repository of Docker images. And again, this is just a choice at this moment. You can run your own Docker registry. You don't really need to pay Docker for this kind of thing. You can run it on Google Cloud. But you need some Docker registry to push them out to. And then the final step is using Ansible to take these containers and deploy them on specific servers with specific configuration. Now, I think that Roberto mentioned yesterday that it can be difficult to configure Docker containers, and he mentioned a Go project that allows you to template stuff. So I've developed something quite like that, but in Python. I called it a parameterized entry point, so I should have taken a simpler word to say than parameterized. But there we are, and we will be using this to be able to bring in configuration from Ansible into the instances of the project containers that will be running. So there's two main things I want to jump in. So that's the Docker container itself and how that works, and the Ansible scripts. Those are probably the most interesting things to look at. And of course, the whole project is on GitHub, and so in your own time, you can look at the nuts and bolts of it. And I will probably have some time afterwards if you want to see specific parts of the setup or have questions about how the different parts of the setup work, we will have time to look into that. So let's first look at the Docker container and then look at the Ansible scripts. Now we have a magical moment where I'm going to tell this Mac to mirror the screens, which will work instantly. Does. It actually did. Great. And yes, great. Cool. All right. That's not right. That's less right, I think. I want to go to the other tab. Yes, and that works. Okay. So this is the URL, the second URL I gave you earlier. This is the code not just for the Python project, but also for the whole deployment setup. And like I said, we're going to look at the Docker container first. So of course, the definition of how to build a Docker container is in the Docker file. And the Docker file is pretty simple. So there's two interesting things here. The first is the addition of what I just mentioned, the parameterized entry point, which will make it possible to configure the Docker container. And here you see that the entry point is used by Docker. And the second interesting thing is that there's the configuration here. So what's happening is that we are pushing templated configuration files into the container. And when the container runs, the entry point will take the templates and will fill in the variables with a configuration that Ansible will provide it. And it will then run Django with the configuration, with the rendered templates as the configuration. And in this case, there's two interesting things to configure. One, of course, are the settings. And the other interesting thing is the initial data, because like I mentioned earlier, what we want to do later is to deploy pull requests. And that means that we can't use the same database for not only production, but the different pull requests will need to have their own database. And it's usually useful to give test data to these test deployments so that a product owner who is trying out a new feature has some data to play around with in the test setup. So if we look at the configuration that we're pushing to the Docker container, it's simply a Jinja template. So in this case, what we say is, okay, if we get a database configuration from our Ansible scripts, we will configure the Postgres database connection with that configuration. If it's not there, we will use the standard development configuration, which will just create an SQLite database on the file system itself. All right. So this is so what the effect of this is that you have a Docker file that is more configurable than normal Docker files. Now I'm going to show you very quickly how these Docker this thing is built, because that's really very simple, and then we'll move on to the Ansible scripts. So because we're using Travis, the definition is contained in the travis.yaml file, but that's really very simple. We use a generic image from Travis that just has Docker, and we just call our own integration script, and we are not using any of the specific Travis configuration, and that means that this setup can run basically everywhere. So if we look at the scripts, we see that it uses little snippets of shell scripts for the individual steps. And these are basically what you would expect. So the build script, for example, just builds the Docker image, nothing more. The test script just runs a Docker image, and in this case, we're using behave to test the project, so it just runs the behave tests. And then publishing, that just means pushing it to Docker Hub. So there's really nothing special about this whole thing, and just the deployment scripts, that's where it starts to become interesting, because that's when we start to run Ansible. And even Ansible is run inside of a Docker container, so that you're not dependent on the version of Ansible that's installable on the system that you're using the integration on. So this is so now I've shown you how the thing is built and what the Docker container is like. And now we will jump into the Ansible stuff to see how this container is deployed and configured on the hosts. So the configuration for that is in this Ansible directory. Now, to determine how much I should tell you about Ansible itself, I would like to know How many of you have ever used Ansible or know how it works? Okay, so that's less than half. So I will give a very brief overview of how Ansible works. Ansible is like I said, an infrastructure orchestration tool. And basically what this does is it has an inventory of hosts. It decides what to do with those hosts by running what's called playbooks. And playbooks are composed of tasks to run. And so that means that when I look here in the inventory, I see that I have basically just one host, which is the registronavale.com domain. This is one host. And it's part of two groups. One group is Docker, and one group is registronavale. And that means that it will both run the playbooks that are destined for either of those groups, and it will also take the variables that are assigned to any of those groups. So the playbook is this thing, deploy.yaml. And this does two things. I will start with the bottom because that's the main event of this playbook. It says for all hosts in the Docker group, I will run a set of tasks, which Ansible calls a role, called Docker containers. And I have some extra configuration for that set of tasks, which is that I want it to remove all containers from the hosts that it doesn't know of. And that becomes important later because when you have a pull request, you want to add a container deploying that pull request. And when you merge that or you close the pull request, you want that container to be removed again. And the top play is basically a way of making sure that Ansible can reach the different hosts, because it will add the private key that can be used to access the different hosts. It will add it to the SSH agent. Now, this is, of course, strange to have this SSH private key in something that we are checking into GitHub, right? In a public project, no less. So this is safe because we have some variables here. These files that are that are ends with _vault, they are special encrypted configuration files, and you need to have a password to use the information in these configuration files. And that means that I'm giving Travis this password that can be used to access the sensitive information, and then Ansible can use the password to decrypt the vault configuration files, and that's where the SSH key is, where the private keys for SSL certificates, API keys for external services, all that kind of stuff. We can all add those to the repository, and that's safe because they're encrypted and they're not readable. So if we look at that, it's just, it's just gibberish. So what you're looking here at is the variables that are assigned to every host that is part of the registronavale group. And like we saw in the inventory, our host is part of that group. So all the variables that are defined in these configuration files are applied. And the most interesting stuff is in this configuration file, because it determines the containers that are running on these hosts. Now you see that it starts with a database configuration, and you immediately see that although the name and the user and the host are here in plain text, it references vault configuration variables for the password. So this is a database configuration for the production deployment. And then we have here a set of containers that will be run, that Ansible will make sure are running on the host when it runs that deploy playbook that you saw earlier. So first of all, we want to deploy Postgres, and we want to configure it with database information that we just configured here on the top. And then we add a container that contains our Docker image. And this is the image that was built earlier during the build process. So this is the part where Ansible picks up the image from Docker Hub and installs it. We give it a name. We give it a domain name. And we add, so this is the part where we add variables to the Docker container, and these are the variables that are picked up by the parameterized access points and are then used in the templating to render the configuration, the instances that are run when this container is running in this configuration. And in the end, you see that it's linked to Postgres so that it can access the database. Well, I add another container that's running the same Docker image, only it's running the admin interface instead of the API, so that you can reach the admin interface and add stuff there. We add another container that contains the HAL browser. People who went yesterday to my talk know what this is about. This is also a tool to browse the API. Then we add a container that's doing the SSL termination for us. So this container makes sure that all the containers that are that you just saw that have a web domain environment are accessible using HTTPS on that domain. So these certificates are wildcard certificates to make this all work. And you can add other containers. For example, Logspout is a container that picks all logging from the other containers and sends the logs to your favorite logging service like Loggly or Logtails or Papertrail, stuff like that. And so you see, this is the description of the whole deployment of the application, of the Django application, not just the Django application itself, but also the supporting tools like the database and Nginx and stuff like that. Of course, this is just a production environment. And what I said is that we wanted to deploy not just production, but we wanted to deploy every pull request. And so there's a little tail here, because this set of roles, the Docker container role that was added to the playbook, also supports templates. And this is a bit of the special sauce that's in the role playbook. So what this does, it takes a GitHub project and looks at all the pull requests that are present there. And then it looks at this Docker Hub repository and looks whether there are Docker containers for those pull requests present on Docker Hub. And if it finds one, it will add it to this host, and it will use this name, then add a dash, then add the PR and the number of the pull request, and then add the domain base. And that means that the first pull request, the container will be API-PR1.regestionavalley.com, and the second pull request will be hosted at API-PR2.regestionavalley.com. And so all the different pull requests are deployed at the same time, all on this same machine. So like I said, I'm not interested. I'm mainly interested in Docker for this functionality and not necessarily for the scalability stuff, because it's my personal opinion that if you have scalability problems, then you may count yourself lucky. Most of us really don't have scalability problems anymore. And we have some variables that are applied to just these Docker containers. So this is how that all fits together. And just to show you how that works, I'm going to create a pull request and then we'll watch the whole system go through the motions of building and deploying the new pull request. And of course, that will take a few minutes, so that's I will start taking questions then too. So going back to the this project here, we have already an open pull request, but that's not the one I'm interested in. I'm going to create a new pull request. And I'm interested in deploying a version of the API that updates the version number. So to very quickly show you what that means, I can go to browser. So this is the browser for the API, and the interesting thing is that it's version 1.0.1. And, oh, that's the wrong one. And the commit here changes that to 0.2. This is a very small change, but let's see how that change is propagated through the build system. So, make a pull request. All right, it's a pull request. And we go to, this is Travis CI, and it's, let's see if it's picked up on the pull request yet. Yeah, it's seen that there's a pull request here, and so we're going to look. It's not starting yet, but we should be seeing something here when Travis has a host free, and we'll see the whole deployment stuff going on here. So while the system is thinking, do you have any questions? So if you say no, we will be sitting here quietly, of course, right?
Hi. Actually, it's a silly question. I wanted to know what you meant before with your comment on scalability. You said something like it's not a problem.
Oh yeah, sure. So so for example, at GoAbout, we have a trip planner that is doing some 80,000 planning requests every month. And we do have scalability problems, but they're in the sense that we need 10 servers for doing planning. That's not scalability problems in the sense that I need to scale to 20 servers at 10 in the morning, and then at 1 I can do with 5 servers, and then in the evening we need to scale up again, stuff like that. So stuff like that is really hard, like flexible scalability to set the limits and to make sure that this always works, stuff like that. And I know that Kubernetes, for example, does this very well, but I have never yet seen a project where this kind of stuff is so important that it's cheaper. It's usually cheaper just to dimension this stuff in the project that I've seen than to try and develop a system that scales dynamically. Where is it? Where is it? Where's the logs? Ah, there's the log. Okay.
Other questions?
Yeah.
No, okay.
Oh, okay. So it's now running the log, right? And it's done the build phase already. It has tested it. And it's now publishing the new container that contains the code for the pull request to the Docker Hub. And then after that, it will run Ansible. Now, let's see if I can show you more interesting stuff from this. So The interesting thing about this is that there's really no magic beyond the Ansible scripts. So if you look at the role here, it's really this is really a self-contained system that doesn't really use any outside magical stuff. So if you look at the tasks, they are pretty straightforward. So they have variables, of course, because we need to use the right variables for the container. But they are pretty easy to follow on. You want to get information, you want to create the configuration, you want to update and start the containers and use the correct information. You want to fail on errors, you want to stop unknown containers and remove the configuration for the containers that you wanted removed. And so that means that even diving into the nuts and bolts of the setup, it really stays quite simple. Yep. So let's see how far along this is. So it's now running the Ansible job. And you see here that it's seen that there's a new container here, which it has called API_PR2 because it's the second pull request. And it's now downloading the correct Docker container. And it's finished. And so this means that at this moment, the new Docker container should be up. And so now, instead of going to api.registernavali, I will go to api-pr2.registernavali. And you see that this version has 0.2 version. And now, of course, the interesting thing is what happens now is that, of course, now you have this pull request. And in the pull request, you can start to discuss these changes, right? So the developers talk about the code quality assurance talks about whether the code quality is correct. The operations guys talk about what this means for the database systems, memory usage. Customer support can talk about whether the documentation has been updated or not, or whether we should use different rephrasings. Functional management will talk about whether this will mean increase in support questions or whether we can do any change in the code to mitigate that. And every time you change this pull request by adding a commit to the branch that's in the pull request, it will rebuild the pull request and redeploy the new version of the pull request. And so once everyone is satisfied with the result, you can push here the green button, and we confirm the merge. And now, of course, Travis will pick up the change here and rebuild the master branch. And by building the master branch, now it will first of all remove the APR-PR2 container that was just brought up, but because that's no longer needed. And the second thing is that the production environment will be updated with the new merged version, the new commit from the master branch. And so next time after this is finished, when you go to api.registernavali.com, it will say version 0.2. That's it. Thank you very much.
Thank you. Any questions?
Well, first of all, thank you for information shared.
Sure.
You previously mentioned the chance to host your Docker container at home, basically not on Docker Hub.
Yes.
I would ask you what's your experience about this topic, and if you have issues in Travis accessing your server.
I haven't. So the second question can't really be answered. So I have tried. Google on their Google Cloud platform also has a Docker registry. I've tried that, and that works. And I've not been in an environment that required a specific container, but you will have a problem because Travis doesn't really have a determined IP range for their build infrastructure. They're using Amazon, so you can't really restrict access. So you can't really then use Travis, but you can use Bamboo or Jenkins or anything else. And because also the build system is Dockerized, it should be very easy to pick up the whole system and run it somewhere else. Yeah.
Okay, thanks.
Fine, yeah. Thank you.